A violent eruption lifts away from the sun and begins crossing the emptiness between worlds. It does not take centuries. It does not even take weeks. Material from a major solar eruption can reach Earth in roughly 1 to 3 days. The distance sounds enormous until the storm is already on the way. Then the sky starts changing. Green and red auroras appear far from the places where people expect to see them. Above dark cities, the glow spreads across the night. It looks beautiful. It looks harmless. But the Carrington event began with the sun, and this kind of light is not just scenery. For a moment, the image feels simple. The atmosphere glows, the colors move, the sky reacts. Then the meaning changes. If this were only an aurora, it would remain a visual event. Instead, the glow marks physical pressure arriving at Earth. The storm does not stay in space. Earth's magnetic shield becomes the first system forced to respond. Most people would see the sky before they see anything else. That is the problem. The first visible effect is not the main danger. The light overhead is evidence that something has already reached Earth. An environment that seemed distant is now interacting with the planet itself. The aurora becomes a warning sign. And if the sky is already reacting, what hidden systems are being forced to react next? That question matters more today than it did in 1859. Because modern civilization depends on systems that share the same foundation: power, communication, navigation, finance, different systems, same foundation. Most of them appear independent. Many of them are not. And if a solar storm can reach the foundation beneath them, the problem is no longer the storm itself. The problem is what happens after the first failure spreads. Telegraph lines stretched beneath an aurora-lit sky. The colors were visible far from the polar regions. At first, it looked like the same warning sign from the previous block. Then the wires started reacting. During the Carrington event in 1859, telegraph equipment was disrupted by a severe geomagnetic storm. Sparks jumped from telegraph keys. Operators were shocked. In some offices, people stepped back from equipment that was suddenly behaving in ways it should not. One image stood out. A telegraph key sparked in a dark room. The system was supposed to depend on its own power source, yet some telegraph lines continued operating even after batteries were disconnected. The equipment should have gone silent. Instead, it remained active. That changes the meaning of the aurora. If the storm were only overhead, the wires should have stayed passive. They did not. The wires began acting like part of the storm itself. Technology became part of the storm path. A small wired world was already vulnerable to pressure arriving from space. Human systems were no longer separate from solar violence. They could accidentally invite it inside. The danger was not only arrival, the danger was entry. And if simple telegraph lines could become a pathway, what happens when an entire planet depends on connected systems every hour of every day? A warning icon blinks beside live solar data. Far above Earth, satellites watch the sun. They detect major eruptions long before the strongest effects arrive. Today, space weather monitoring can see the threat coming. For a moment, this feels like a solved problem. The Carrington event now has satellites watching for its return. But look at the actual clock. A spacecraft positioned near the L1 point between Earth and the Sun can provide roughly 30 to 60 minutes of direct warning before the incoming wave reaches Earth's magnetic environment. That is the protection window. The threat may be visible. The countdown is still short. In 1859, the storm arrived with little warning. Today, operators may know exactly what is coming. But knowing is not the same thing as stopping it. Preparation sounds like protection. They are not the same thing. If prediction equals control, a warning should make the next impact manageable. Yet the warning screen can only start the protection clock. It cannot reach into the systems that must survive the storm. The warning remains visible. The clock keeps running. And that creates a different question. What if the real problem is no longer seeing the storm coming, but whether modern systems can absorb it after everyone already knows it is on the way? Current paths appear across a grid map. Long transmission lines stretch over open land. Substations remain connected. Transformer yards sit beneath the same sky that satellites have already flagged as dangerous. Everything appears ready. Then the pressure arrives anyway. Grid models show that a severe geomagnetic disturbance can drive currents through power systems. The forecast may be correct. The warning may arrive on time. The countdown may begin exactly as planned. The current still enters the grid. That is the contradiction. A warning icon can blink on a screen hours before impact, but it cannot physically stop geomagnetically induced currents from moving through long transmission lines. The storm is no longer being tracked. It is now interacting with hardware. A transformer yard hums beneath an aurora-lit sky. For a moment, nothing looks dramatic. Then stress begins building inside equipment that most people never think about. The weak point is no longer detection. It is endurance. Large transformers can be expensive, custom-built, and slow to replace. That changes the meaning of preparation. The question is no longer whether the storm can be seen coming. The question is whether the infrastructure underneath modern life can survive after the warning arrives. Because if the forecast is right and the transformer still takes the hit, the danger shifts from impact to recovery. And if power loss lasts longer than the storm itself, what else begins failing while the grid is still trying to come back? A city stays lit beneath a restless sky. Traffic lights continue changing. Cell towers remain connected. Payment screens still work. Water pumps keep moving. Hospital backup systems wait in the background. Everything appears separate. Then parts of the same foundation begin failing. One power node goes dark. A connected system follows. Then another. What looked like independent networks starts revealing hidden links. A traffic signal shuts off. A cell tower loses power. A payment screen goes blank. The problem is no longer a single piece of equipment. Power supports communication, water, finance, traffic, emergency response, and much of the infrastructure people use every day. If modern systems were truly separate, one failure should stay contained. But they share the same electrical foundation. That changes the meaning of the threat. The Carrington Event is now a modern dependency test. The storm does not need to damage every system directly. It only needs to damage the foundation underneath them. Even backup systems can depend on parts of the same electrical world they were meant to protect against. The city becomes quieter. Not because everything was destroyed, because too many systems were connected. And suddenly the words "not prepared" no longer describe the storm. They describe the assumption that advanced systems fail separately when many of them were depending on the same thing all along. So if the chain matters more than the storm itself, are we actually prepared for the cascade that follows?